Good morning, everyone. We are the Group 10 and we will be talking about software testing implementation. So, the testing process. Planning, design, and performance of testing are carried out throughout the software development process. These activities are divided in phases, beginning in the design stage and ending with the when the software is installed at the customer site. So, determining the test methodology phase. The main issues that testing methodology has to contend with are first, the appropriate required software quality standard and the software testing strategy. Decision about these two issues are fundamental and must be made before planning begins. The first is, as you can see in the figure, that determining the test methodology. Next is planning the test. Next, designing the test. And lastly, performing the test or implementation. Next is that determining the appropriate software quality standard. The level of quality standard selected for a project depends mainly on the characteristics of the software's application. Example number one, a software package for a hospital patient bed monitor requires the highest software quality standard considering the possibly severe consequences of software failure. The example illustrates the main criterion to be applied when choosing the software quality standard, the evaluation of the nature and the magnitude of the expected damage in case of system failure. These damages may affect the customer and users on one hand, and the developer on the other. In general, the higher the expected level of damage resulting from failure, the higher the appropriate standard of software quality. There are examples. These are the type of damage to customers and users. First is endangers the safety of human lives. Examples are weapon systems, hospital, patient monitoring system, and aeronautical and aerospace systems, and many others. While the damage to software developer, example is financial loss. Example is damages paid for physical injuries, paid to organizations for malfunctioning of software, purchase costs reimbursed to customers, and high maintenance expense for repair of failed systems, and many more damages to the software developer. Next is determining the software test strategy. The issues have to be decided include the testing strategy. Should a big bang or incremental testing strategy be adopted? If incremental testing is preferable, should testing be performed bottom up or top down? Which parts of the testing plan should be performed according to the white box testing model? And lastly, which parts of the testing plan should be performed according to the automated test modeling? Planning the test. So what to test? The test to be planned include unit tests, integration tests, and system tests. So it is incumbent upon planners to consider the following issues before initiating a specific test plan. First is what to test. Next, to be followed by which source to use for test case. Next is who is to perform the test, where to perform the test, and lastly, when to terminate the test. These five issues will be discussed single-handedly. The first is what to test. A straightforward approach to perfect testing would recommend a full and comprehensive software test plan that requires performing unit tests for all the individual units, integration tests for all units, and a system test-to-test software package as a whole. Relatedly, certain questions will undoubtedly arise with respect to common situations that pertain to the benefits of such an approach. For instance, is it justified to perform unit tests for a module composed of 98% real software, and many more? The next is rating units, integrations, and applications. The methods for rating units, integrations, applications to determine their priority in a testing plan are based on two factors. These are factor A, damage severity level, the severity of results in case the module or application fails. Next is factor B, software risk level. The level of risk represents the probability of failure. In order to determine the risk of a module, unit, integration, or application, the issues affecting risk require explanation. These issues can be classified as a module application issues and programmer issues. Next is generating a combined rating based on two factors. The combined rating C will be based on the ratings for A, the damage severity grading, and B, the risk severity grading. C can be calculated in a variety of ways. For instance, C equals A plus B, C equals K times A plus M times B, C equals A times B. Where K and M are constants, the inclusion of a unit, integration, or application in a testing plan and the amount of resource allocated to each test depend on priorities as expressed in the combined rating. In order to determine these priorities, initial calculation of the ratings is necessary. As a rule, the higher the rating, the higher the testing priority and the greater the allocation for testing resources. Next, which source to use for test case? The planner should consider which of the two main sources of test case samples of real-life test case and or synthetic test cases are most appropriate to their needs. Each component of the testing plan dealing with unit. Integration or the system test requires an individual decision about the respective test case and resource. The first is the use of a single or combined source of test cases or both, followed by how many test cases from each source are to be prepared, and lastly, the characteristic of the test cases. So who perform the test? Who will perform the various tests is determined at the planning stage. Integration tests, but especially unit tests, are generally performed by the software development team. System tests are usually performed by an independent testing team. It may be internal testing team or external testing consultant teams. And lastly, in case of large software systems, more than one testing team can be employed to carry out the system test. The prerequisite decision to be made in such cases concerns the allocation of system tests between the internal and the external testing teams. While in a software development organizations where a separate testing team does not exist, the following testing possibilities nonetheless exist. First is testing by another development team. Each development team will serve as the testing team for projects developed by other teams. And lastly, outsourcing of testing responsibilities. Where to perform the test? Unit and integration testing are naturally carried out at the software developer's sites. Location becomes important only when system tests are concerned. Should they be performed at the developer's sites or at the customer's site, or the target site maybe? If system testing is to be performed by external consultants, a third option arises: the consultant site. The choice depends on the test or system's computerized environment. So when are tests terminated? The decision about the stage at which software testing should be terminated is meaningful mainly with respect to system tests. There are 5 criteria on this. The first is the completed implementation route. According to this route, this uh, testing is terminated once the entire test plan has been carried out and error-free or clean may be. Results are achieved for all the required regression tests. The next criteria is the mathematical models application route. Testing would be terminated once the error detection rate declines below the rate that corresponds to a predetermined level of undetected errors, which is considered an acceptable software quality standard. The next is the error seeding route. This approach, errors of various types are hidden in tested software prior to the outset of testing. The underlying assumption of this route is that a percentage of discovered seeded errors will correspond to the percentage of real errors detected. Next is the dual independent testing team route. If this route is adopted, two teams implemented the testing process independently. The list will be prepared as follows: NA number of errors detected by team B and NB number of errors detected by team B. The following count of detected errors is arrived at for comparison of the list. NAB equals number of errors detected by both team A and team B. We would expect to find PA errors detected by team A and PB detected by team B, with PAB detected by both team A and B. PAB proportion of errors undetected by both teams, NAB errors undetected by both teams, and lastly, N total number of errors in the software package or program. And lastly, termination after resources have petered out. Wait for a while. Termination of this type occurs with budgets or the time allocated for testing run out. The situation, unfortunately not uncommon in the software industry, is of course undesirable. Next is test planning documentation. The planning stage of the software system is commonly documented in a software test plan or STP. Next is test design. The product of the test design stages are first detailed design and procedures for each test and test case database or file. The test design is carried out on the basis of the software test plan as documented by STP. The test procedures and the test case database or file may be documented in a software test procedure documented and a test case file documented or in a single document called the software test description (STD). Test implementation. Testing implementation phase activities consists of a series of tests, corrections of detected errors, and retests or regression tests. Testing is culminated when the retest results satisfying the developers. Retesting is conducted to verify the errors detected in the previous test runs have been properly corrected and that no new errors have entered as a result of faulty correction. It is quite common to find that the correction regression testing sequence is repeated 2 to 4 times before satisfactory test results are achieved. It is advisable to retest to the original according to the original test procedure. Test case. The next topic is test case design, which is under test case data components. A test case is a document set of the data inputs and operating conditions required to run a test item together with the expected results of the run. Example, consider the following test case for a basic annual municipal property tax on apartments. The basic municipal property tax is based on the following parameters: S, the size of the apartment in square yards, N, the number of persons living in the apartment, A, B, or C, the suburb socio-economic classification. The following are the three cases for the software module used to calculate the basic municipal property tax on apartments. Test case sources. There are two basic sources for test case. First is random samples of real-life cases. Examples are a sample of urban households. The next is synthetic test cases, prepared by test designers. This type of test case does not refer to an existing customer, shipment, or product, but to combinations of the system's operating conditions and parameters, which is defined by a set of input data. The next topic will be discussed by my teammate, Mr. Damolo. Thank you.
So Automated testing. Automated testing represents an additional step in a integration of computerized tools into the process of software development. Several factors have motivated the development of automated tested tools, including anticipated cost savings and shortened test duration. The possibility of efficiently performing various classes of tests previously not feasible or impossible to perform manually, such as load tests, has likewise propelled the drive for investment in automating testing development. Next, pray. This section covers the process of automatic testing, the types of automated tests, the advantage and disadvantage of automatic tests. Next, pray. The process of automatic testing. The availability of professional manpower is one of the main factors to be considered before initiating automated software tests. It is the computerized test performance and the reporting that yield that main economic quality and timetable advantage of the process. To better understand the issue, a comparison automatic and manual testing is presented in table 10.4. Next, pre. Next, pre. Di katong table. Kana. So kani guys kay gi-compare ang automated og manual testing nya ang mga steps sa proseso kay naras pinaka left sa table. So next pre. Itong types of automated tests kana. The more established automated tests are mainly those employed for testing tasks that have a high number of regression tests and those performing test classes not feasible for manual testing such as load testing. Next, pre. Code auditing. This test performs automated qualification testing. The computerized code auditor checks the compliance of code to specified standards and procedures of coding. The auditor's report includes a list of the deviations from the standards and a statistical summary of the findings. Next, pre. Katong kana. Coverage monitoring. Coverage monitors produce reports about the line coverage achieved when implementing a given test case file. The monitor's output includes the percentage of lines covered by the cases as well as listing of uncovered lines. These features make coverage monitoring a vital tool for white box tests. Next, break. Functional tests. Automated functional tests often replace manual black box correctness tests. Prior to performance of tests, these tests, the test cases are recorded into the test case database. After the correction have been complete, retesting the whole program is commonly required. It is quite common for a program to require 3 or 4 regression tests before its quality level is considered satisfactory. Next, pray. For load tests to be performed, the maximal load environment must first be created. If executed manually, the test must be conducted when the system is under maximal user load. The only way to carry out load tests for medium-sized and large systems is by means of computerized simulation that can be programmed to closely approach real load conditions. A virtual user or even emulates the behavior of a human user or a real events. Its behavior is constructed by applying real outputs from real user application. The simulation required loads and frequencies are also created by computerizations. The tests are carried out with a final approved version of software and with a planned hardware and communication configuration. Next, play. For example, a tester may wish to change the hardware, including the communication system, to allow the software system to fulfill its performing requirements at each load level. Change the scenario order to reveal the load contributed by each user event. Test an entirely different scenario. Test new combination of hardware and scenario components. Next, play. Tester will continue his interaction while he finds appropriate, ano, appropriated hardware configuration. Example. Pwede na post pre, kita ko kung ano eh. Lula na eh. Mapuha sa pre. Inom sa. Hindi. Dating the ticket is a new internet site planned to meet the following requirements. Slide pre. The site should be able to handle up to maximum of 3,000 hits per hour. The average reaction time required for a maximum load of 3,000 hits per hour is 10 seconds or less. Average reaction time required for a regular load of 1,200 hits per hour is 3 seconds or less. Next frame. Plan. The load tests were planned for following series of hit frequency hits per hour: 300, 600, 900, 1,200, 1,500, 1,800, 2,100, 2,400, 2,700, 3,000, 3,300, and 3,600. An initial hardware configuration was defined to be adapted according to the load test results. Implementation. Three series of load tests were run before the adequate hardware and communication software configuration was determined. After the first and second series of load tests, the hardware configuration was changed to increase the system capacity so as to achieve the required reaction times. The second configuration fulfilled the reaction time to requirement for average load, but not for a maximal load. Therefore, capacity of further increase it is a final configuration. The software system could satisfactorily handle loads 20% higher than the originally specified maximal load. See table 10.5 for average reaction to measure the each round of load testing. Next break. Next break. Kana mo to table. Kana. O kani guys kay i-compare ng average reaction time sa load test sa series 1, 2 ug 3. Next break. Time test. Test management. Automated test management software package to provide feature applicable for manual as well as automatic test and for automated test only. In general, computerized test management logs are planned to provide test service reports, lists, and other types of information at level of quality and availability that are higher than those provided led by manual test management system. Next, pre. Kana. The availability of automated test tools. Most of the automated testing tools are specialized and planned for sure for use in specific areas of programming system application, client server, system C++, Unix application of a specific software house, enterprise resource planning application to cite just a few. The variety of tools currently offered covers most prevailing programming areas and applications, and they are readily available from the software development companies specialized in automated testing tools. Next, break. Advantage and disadvantage of automatic tests. The decision of employing automatic testing tools is difficult to make because of the substan 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 substantial I sub, substantial investment involved in purchasing the tools and adequately training a team. Quantitative comparison, especially in economic analysis based on the empirical data, is surely needed to support the qualitative comparison. The first part of the reaction presents a comprehensive qualitative comparison of automatic testing and manual testing display. The main advantage of automated tests are number one is accuracy and completeness of performance. Computerized testing guarantees to the maximum degree possible that all the tests and test cases are carried out with completely accuracy. Manual testing suffers from period of testing where or low concentration rates that endure inaccurate keying in or the test case omission and so forth. Retoise accuracy of result lag in summary reports. Automated tests are programmed for accuracy of reporting of errors detected. Number three is comprehensiveness of information. Naturally, once the test data, including test results, are stored in database, queries and reports about the test and its results are incomparably more available than the same items would be after performance of manual tests. Next, pre. Therefore, is few manpower resources required to perform tests. Manual performance of testing in comparison in a major consumer of manpower resources. Lastly, shorter duration of testing. The duration of computerized testing is usually far shorter than the manual testing. In addition, automatic tests can be carried out uninterrupted 24 hours a day, 7 days a week, in contrast to manual testing, which might require one testing team to work 3 shifts a day or alternative to employ 3 testing teams, both being rather impractical in the most cases. Ah. Then, six is performance of complete regression tests. Because of the shortage of time and manpower resources, manual regression tests tend to be conducted on only a relative small portion of the software package. Hence, the advantage of automatic testing, the minimal time and manpower resources required make it possible to rerun tests based on the previous results. Number seven is performance of test classes beyond the scope of manual testing. Computerization enables to test to perform like perform. For example, the load test, availability test, and efficiency test for medium and large scale system. These tests are almost impossible to perform manually on system of God greater than the small size. Next, pray. Okay, next. The main disadvantage of automated testing are highly investment required of package purchasing and training. An organization that decide to implement automatic testing must invest in software package and additional training to qualify its staff to perform those tests. Despite the claims of software package development, although the amount of training varies by software package, it is still long and thus expensive. Number two is high package development investment costs. In case where available automated testing package do not fully suit the system requirements, custom-made package must be developed. Next, break. Number three is high manpower requirement for test preparation. The human resource required for preparation automatic tests procedure are usually substantially higher than those required for preparation of manual procedure for the same software package. Number four is considerable testing areas left uncovered. At present, automatic software testing packages do not cover the entire variety of development tools and types of application either available manually or still needed. This forces testers to mix manual and automatic testing in their test plans. Next, break. Quantitative comparison, empirical findings. The time takes to prepare a computer for automatic testing is 65% more consuming than that for manual testing. According to Dustin et al., the authors estimate n the minimum number of test runs that a community justify application of automatic testing as the break-even point. Now, next, pray. So, kalayaan sa preparation time o testers run executive time kay kaya nila kay mo na kuan kalayaan nila og kuan ng manual ay kalayaan nila sa preparation og testers run kay sa automatic og manual testing. Next, pray. So, similar to those investment in the first test run and can be derived according to the following equation. 19.2 plus 0 ay 0.21 times n is equal to 11.6 plus 3.93 times n equals to 2.4. Next, play. So, based, based on the model, if the testing process requires more than one regression test run, automatic testing is to be preferred. Some reservation, including those mentioned by Dustin et al. 1999, are evident. The break-even point model ignores or considers negligible the heavy investments required for acquiring automatic testing capabilities and its regular upgrading. Manual regression test runs, usually second, third, and later regression runs are usually partial, therefore requiring only a portion of the resource consumed during the first test run. Automated test runs are carried out without any human interaction during the run. No modifications preparation report are required to automatic test fast for performing regression tests. Next, pre. So it should be emphasized that even if consider considering the above reservation would change and to be n equals 4 or more, the important qualitative advantage of automatic testing would lead us prefer the manual testing in many cases. Much additional research is needed to be construct a comprehensive integrated model for the comparison qualitative and qualitative of the two testing approaches. Next, brief. So alpha and beta site testing programs. Next, brief. Alpha site tests are are tests of the new software package that are performed at the developer site. The errors identified by alpha site tests are used by reusers can reveal and thus should be reported to the developers. Alpha site testing enjoys the same advantage and displays the same disadvantage as beta site testing. Hence, are usually more difficult to organize than beta site tests, but tend to be fruitful. Next, three. So beta site tests much more. This is much more efficient and this much commonly applied than are applied described as follows. At the developer testing occasionals and beta site tests are considered to be viable tool. Some developers involve hundred or even thousand of participations in process. Next page. Main advantage of beta sites test. So identification of unexpected errors. They reveal errors of a type that next page. The identification of unexpected errors. They reveal errors of a type that professional testers rarely identify. A wider population in search of errors. Wide range of participants involved in beta site testing and the base of scope of software usage, experience, and potential revealing hidden errors that go beyond those available at the developer's testing site. Low cost. The only cost encountered are the price of the package and its delivery free of charge to the customer. Low sales are relatively low. Next, pray. Main disadvantage of beta site tests. Next, pray. Next one. Lack of systematic testing. No obligated to prepare orderly reports. Reports gathered, experience, and leave untouched application as well as segments of those applications. Low quality error reports. Participants are not professional testers. Errors are often faulty. Some report no report at all, and it is frequently impossible to reconstruct the error condition they report. Difficult to reproduce the test environment usually performed in a uncontrolled testing environment that creates difficulties when attempting to identify the causes of the reported errors. Lastly, much effort is required to examine reports. A, rev- relatively high investment of time and human resources is needed when examining reports due to frequent repetition and low quality of reporting. So that's all. Thank you.